So now that we have a chance to talk about a number of Java synchronizers, things like reentrant lock and semaphore and condition object, I want to take a step back and talk about some of the more foundational concepts in the Java memory model that are necessary for all the synchronizers to behave in a sensible way. And we're going to begin our discussion with something called happens before relationships. And the first discussion here, of course, will be what does it mean to happen before in Java? Understanding these concepts are actually quite important to really mastering concurrent programming. You can get a long way without really understanding the concepts in detail, just because you can learn about how to use synchronizers like reentrant lock or semaphore and so on. But to really understand what's happening under the hood and what behaviors are being induced by these synchronizers, you have to understand the concept of happens before. So let's start even further back by discussing what happens in single-threaded Java programs, where the happens before relationship is super easy to understand. So every action in a single thread, in other words, a single-threaded Java program, happens before every other action in that thread that occurs later in the program order. So if you take a look here, you can see we have a bunch of statements in one thread of control. And of course, statement 2 needs to happen before statement 3, and statement 3 needs to happen before statement 4, and so on and so forth. And that's just because of the lexical nature and the sequential lexical nature of Java code. And we discussed this a little bit when we talked about Java volatile variables much earlier in the course. When I think about happens before relationships in a single thread, the image that always comes to mind is a taxi stand at, say, an airport or an event or hotel, where the taxis queue up and the next taxi that's in the front of the queue gets the next person who wants a ride. So it goes in strictly sequential order. So the first taxi cab picks up a rider before the next one. In multi-threaded programs, however, actions in different threads can actually occur in different orders. And this can cause you all kinds of chaos and insanity if you don't use synchronizers correctly. And so this is really kind of at the heart of thread safety and trying to find ways to avoid some of those concurrency hazards we've talked about before. So in that context, where we actually have multiple threads of control, a happens before relationship is essentially a guarantee by a computing system that if one action happens before another action, the results must therefore reflect that ordering. And you can see here's a very simple example that we'll explore in more detail momentarily, where we have two threads, thread A and thread B. And as you can see, we come in here and thread A sets the value in some field Y to 1. It acquires a lock. It sets the value X to 1, and then it unlocks the lock. Now, assuming thread B had come along at any point and it had tried to acquire that lock after the thread A had acquired the lock, of course. So what'll happen there is after thread A unlocks the lock M, then everything that occurred before the unlock occurred in thread A will be visible after thread B acquires that lock. So that's what it means to happens before. And we'll talk more about that. Now, one of the things that's important here is there's a need to be able to have concurrent programs properly signal the order in which they want actions to occur. And of course, that's done by using synchronizers. Now, the interesting thing about this is underneath the hood, the Java execution environment, the virtual machine, the runtime, whatever it does to carry out the operations on Java code, the actions can actually occur out of order. And that's to be able to enhance the program flow and enable certain optimizations. So things don't always have to happen in exactly the order that they're written textually or lexically in your program. However, the behavior does have to occur in the proper order when synchronization is in play. And that's why if you don't synchronize things properly, you can get very strange results because these out of order instructions won't realize that they have to essentially be ordered by some other means. So in Java, a happens before relationship is a guarantee by the underlying execution environment that an action performed in one thread is visible to another action in a different thread. So here's a very simple example where we have thread 1 and it sets answer to 42 and ready to true. And then what you want to have happen is you want to have thread T2 be able to see those things in the right results. And if you use synchronization properly, then thread T1 will complete its writes to answer and ready. In other words, they will have been propagated through the memory hierarchy before thread T2 starts its read of ready and answer. If you don't use synchronization properly, then it might be the case that ready would be set to true, but answer might not be set to 42. And that's because, of course, you can have out of order execution taking place under the hood in the Java model without use of synchronization. Now, we've talked before about some of Java's atomic variables, things like the volatile, we talked about atomic integer, we talked about compare and swap, we talked about var handles, and these are all used to properly enforce happens before relationships on single variables. So you're writing to an atomic integer, or you're writing to an atomic Boolean, or you're storing something in a volatile, and so on and so forth. So using volatile as a simple example, as we saw before, what happens there is that you have one thread that will write to a volatile, and that will happen before some other thread tries to read from that volatile. So you'll end up getting a consistent value. It doesn't go through caches, it goes directly to memory, and it's properly synchronized. However, the interesting case is actually not something that's handled by these simple single operations on atomic variables and atomic objects. Instead, we're going to be focusing here on happens before relationships that involve objects with multiple fields. So going back to our earlier example we looked at when we first discussed the concept of atomic, happens before relationships, you can see here we have thread A, which is going to be modifying field Y and field X. And then we have thread B, which is going to be reading the value of X and reading the value of Y. And what we want to have happen here, of course, is we want to make sure that these operations occur in such a way where they're consistent by the time thread B goes to access them. It won't get some variant of the value Y and some other different variant of value X. Those things are happening atomically. And these relationships try to ensure that you can have these sort of multi-variable or multi-field relationships working properly, require more elaborate synchronization mechanisms than just something like a volatile or something like a atomic operation. So of course, we'll show some examples of those just in a minute. But for right now, this is a summary of the finishing of our introduction to the concept of happens before relationships, which is really the conceptual model upon which the Java synchronizers work.